Dear students, today we discuss chapter number 2, that is solution. It carries 5 marks. One question of 2 marks and one question of 3 marks will be asked in MPBSE examination. At first, we define solution. How we define solution? Homogeneous mixture of solute and solvent is known as solution. Homogeneous mixture of solute and solvent is called solution. The substance which is present in large amount is known as solvent, and the substance which is present in small amount known as solute. Solvent is those substance in which there is no change in physical state, while the physical state of solute may be changed. Solution is a homogeneous mixture of solute and solvent. Now, second, we define types of solution. On the basis of amount of solute present in it, the solution is mainly classified into 4 groups. Number 1, dilute solution. Solution in which the amount of solute is less than required amount. Then concentrated solution. Concentrated solution. The solution in which the amount of solute is relatively very high. Then saturated solution. Solution which contains maximum amount of solute at a given temperature and it is unable to dissolve more amount of solute is called saturated solution. Next and fourth one, super saturated solution. Solution which has excess of solute in solution required for saturated solution. It is called super saturated solution. Here, the excess of solute can be separated by applying filter paper. So these are the 4 types of solution. Now, today we discuss concentration terms. Concentration terms. In board examination, in 2 marks, the question is asked from concentration terms. Generally, it may be numerical or definition. So for concentration terms, at first we define normality. Number of gram equivalent of solute dissolved per liter of solution is called normality. Number of gram equivalent of solute dissolved per liter of solution is called normality. It is denoted by capital N. Normality can be calculated with the help of formula. N is equal to W into 1000 upon E into V. Here W is weight of solute, E equivalent weight of solute, V volume of solution in ml. The second formula to calculate normality is N1 V1 is equal to N2 V2, where N1 is the normality of first solution, V1 is the volume of first solution, N2 is the normality of second solution, and V2 is the volume of second solution. Now, second, we discuss molarity. Rita. It is defined as number of gram moles of solute present in 1 liter of solution. Number of gram moles of solute present per liter of solution is called its a molarity. It is represented by capital M. The molarity is calculated with the help of formula mol is equal to W into 1000 upon molecular mass into V in ml. W weight of solute, it is molecular mass of solute, V volume of solution. The second formula is M1 V1 is equal to M2 V2. M1 molarity of first solute, V1 volume of first solute, M2 molarity of second solute, V2 volume of second solute. Now third one is molality. Molality is defined as number of gram moles of solute dissolved in per kilogram of solvent. Number of gram moles of solute dissolved in per kilogram of solvent is called molality, Lalita. It is represented by small m. And molality is calculated with the help of formula M is equal to WB into 1000 upon MB into WA. Here WB is equal to weight of solute, MB molecular weight of solute, WA weight of solvent in kilogram. Now we discuss ppm, parts per million. It is defined as number of grams of solute present in 1 million of solution. It is represented by ppm, and the formula of ppm is amount of solute upon amount of solution into 10 to the power 6. With the help of this formula, we can determine parts per million concentration. It is used when the amount of concentration is very less. Generally, to calculate pollution, we use ppm. Now, next one, mole fraction. How we define mole fraction? It is the ratio of number of moles of components to the total number of moles. It is the ratio of number of moles of component to the total number of moles. It is represented by X. Here we are using term XA for solvent and XB for solid. For binary solution, means where two substance, solvent and solute are present, then if we want to determine the mole friction, then the formula is XA. Mole friction of solvent is equal to number of moles of solvent upon total number of moles. Similarly, mole friction of solute is equal to number of moles of solute upon total number of moles. Mole friction is the ratio of number of moles of one components to the total number of moles. It is represented by X. For solvent we use terms XA, and for solid we are using term XB.